This is Britt Caswell with another example video. This is example 3 from lesson 1-2, Understanding Stretches and Compressions. This is coming from the SavvasRealize Algebra 2 textbook. So what I want you guys to do is imagine that these graphs are made out of silly putty, and you are grabbing either the top and bottom or the sides of the silly putty, and you are either pulling them really, really tight, that's a stretch, or you're kind of mashing them in together, and that would be a compression. Okay, so those are my definitions. So we're going to be dealing with kind of a function that we're pretty comfortable with. We're going to deal with the absolute value function. And I'm reducing the domain, so I'm cutting it into a smaller graph by only looking at from -4 to 4. You should probably recall from Algebra 1 that the absolute value graph is a V shape. It's probably the easiest graph to transform, which is why I'm doing it. So now let's look at what our g of x is. Okay, so the green one's f of x, it's the absolute value of x. So on g of x, what we are doing is we are multiplying the function by 2. So that multiplication tells you you're having either a stretch or a compression. The fact that it's happening outside of the function tells you that it's a vertical change. So that means we are affecting it vertically. And because that value, I'm going to call it a, which you guys will see in other resources. This is an a. Because that a is greater than 1, it's a stretch. Now, if that a value was between 0 and 1, that is a compression. If that value is negative, you need to do the reflection, then deal with the stretch or compression. Okay, we aren't going to deal with a negative a. Alright, the negative is its own can of worms. Okay? So I'm going to teach you this with a t-table. So I have my x values, right? So I'm going to keep it easy. Just pick 5 numbers from within my domain. The 4 and the 2 and stuff makes it really easy to talk about it. And then I'm going to look at the y values, or the f of x values, for that absolute value function. And you see them here on my graph. Alright, the absolute value of 4 is 4. Okay, absolute value of -2 is 2. So absolute values are just describing the distance from 0, so it just turns anything negative to being positive. So now, to talk about a vertical stretch, what we're going to be doing is we are going to be taking these y values, or these f of x values, and we're just timesing them by 2. Okay, so my g of x is just taking this second column and timesing everything by 2. And you should get that pattern right there. So when I go to graph it, I'm going to graph the x and the y, and the x and the y, kind of like that. Alright. So each of these, their distance from the x-axis should be doubling. This 0 is right on the x-axis, so it stays the same. But at 2, instead of going up 2, I'm going to go up 4. And at 4, instead of going up by 4, I'm going to go up by 8, which I ran out of room on my graph, I apologize for. Okay, and that happens over here also. So at -2, I'm supposed to go to 2, but instead I'm going to go to 4. And at -4, I'm supposed to go to 4, but instead I'm going to go to 8. And that gives me this kind of V shape like that, which is kind of cool. Alrighty, so it's important to recognize that when we do stretches and compressions, we need to make sure that we're doing those bad boys before we ever translate, because otherwise you're gonna stretch or compress it too far. So always do these before you translate. Alrighty, so now let's take a look at part B. So part B is similar to part A in that we're still dealing with the absolute value function. We're still dealing with this v. It's getting a little uglier the more hours that I work. So here's our v. Okay. I can still make the same table of values, -4, -2, 0, 2, 4. My f of x values, my y values, still the same. This is where things get a little quirky, okay? So when we have a 2 on the inside of the grouping symbol like this, we don't usually like it there, okay? So what I'm going to do is I'm actually going to factor the 2 out from the x, and it's going to end up looking kind of like this. F of 2 times x, like that. All right, now, kind of a side note, if this had been like f of 2x plus 4, when I factor that 2 out, I'd be doing something like this. Okay? And so this is important because it's talking about a translation, and it's going to change your translation if you don't do it this way. Okay? And so that 2 is my a value. And so if that a is bigger than 1, when it's a horizontal change here, this is now a compression. And if that a is between 0 and 1, pretend that says between 0 and 1, that'll be a stretch. So notice that it's kind of flipped backwards from the vertical ones. Okay, stuff inside the parentheses always feels a little backwards. Okay, and so what I'm actually going to be doing to create my table of values is I'm going to be taking all of the x coordinates. So instead of playing with the y coordinates, I'm going to take the x coordinates, and I'm going to multiply them by 1 over this a value. Okay, so I'm going to do 1/2 of the x column to generate my ordered pair. So -4 is going to be -2. -2 is going to be -1. 0 is still 0. 1/2 of 2 is 1. 1/2 of 4 is 2. And so what that's going to do is that's going to create an ordered pair. They appear a little bit backwards here. But it's going to be at -2, 4. -1, 2, 0, 0, 1, 2, and 2, 4. Okay, again, this horizontal compression is occurring by multiplying 1 over this a value to the x column. So it's x changing, not f of x. Make sure you're super, super duper clear. So now, here we are, I'm going to do h of x and graph those points. So I have -2, 4, -1, 2, 0, 0, 1, 2, and 2, 4. And I'm going to connect those lines. Take a look-see. What do you see? Do you guys see that some of these points are still the same? That the same general shape is there as when I did a vertical stretch? Often with a lot of our graphs, horizontal stretches and compressions look the same as vertical stretches or compressions. It's just a little bit of a difference here, and they're kind of inverted, right? So this is actually a horizontal compression. Let me draw my little terrible hands. This is why I'm not a real artist. Okay, so here's my first hand. Oh, it has an extra finger, sorry. And a thumb finger, that's fine. So what I'm doing is if I put my hands on this graph and I push the green graph in, right, I'm compressing it, it is producing that yellow graph. And so the way that we did that was we found our a value, we made sure to factor it away from all the other stuff in the parentheses. I found the reciprocal of that a value, I put it under a 1, and then I multiplied it to the x's. The vertical changes, you just take that a value, multiply it times the y's. Alright, so that's kind of the change. So maybe I should put 2 times the y value right there. Maybe that makes that more sense. That was ugly. Let's try this again. Okay, so here we are. We are doing another horizontal change because the 1/2 is inside the grouping symbol. Oh, we're zooming out. Let's go back. So if I were to plug in that 1/2 x into my f of x function, right, I'd get that j of x is equal to the absolute value of 1/2 x. Okay, and I'm going to factor that out. Put that x in parentheses so remember I already factored it. So then this is a horizontal change. So what I'm going to do is I'm going to flip this fraction upside down. I'm going to call it 2 over 1. And then I'm going to times it to the x's. Okay, so I'm going to make some ordered pairs here. So there's my ordered pairs. My y values, my f of x's, are going to stay as they are. And then I'm going to multiply each of my x values. It's okay, honey. I'm going to multiply each of my x values by 2. So -4 times 2 is -8. -2 times 2 is -4. 0 times 2 is still 0. 2 times 2 is 4, and 4 times 2 is 8. And then let's graph them. Let's see what we see here. Alright. So here is my same parent function we've been dealing with. And then now we have a saucy pen, it's acting up. So then now I'm going out to -8 and up to that 4. I'm going out to that -4, going up to my 2, 0, 0. I'm going to go back out to 4, go to 2, and then I have an 8. Sorry for the small graph. But here's my new v. So this try it, it says show that this is a horizontal stretch, right? So let's imagine our hands. Okay, it's horizontal, so I'm putting my hands on the horizon of the graph, and I'm pulling it outwards, right? Do you see how the V is becoming wider? And that's it. I will post an additional video explaining these because the horizontal stretches and compressions can be pretty difficult. But hopefully this helped you guys out. Till next time.